All right, hello and welcome everyone to the Filecoin workshop, making storage deals on Filecoin-EVM. Joining us today is Zak Ayesh, who will be taking us through this session. And with that, I will pass it over to Zak to introduce himself and get the session started.
Hey everyone, yep, my name is Zak Ayesh. You might have seen me around on a couple of other Filecoin coding demos. I'm a developer advocate with the Filecoin virtual machine team at Protocol Labs. And today I'm going to go over programming on the FEVM. And you might have seen this talk from me before at previous ETH Global events. But on this talk, we're going to do something a little bit new. We're going to go over towards the end how to make storage deals with smart contracts on the Filecoin virtual machine. So this is a really cool new functionality we've been working on for a long time. The engineers have been hard at work. And so I'm excited to go through this demo with you today. Yeah, so quick story. One of my very first projects interacting with any of the Filecoin IPFS protocols was creating a dynamic NFT. And essentially, it was like this nerdy Schrodinger's cat reference where you would mint an NFT box and it would use the Chainlink VRF and randomly pick when you minted the cat to either be this attack cat or a sleeping cat, right? And this was probably 2 years ago or so now. And little did I know I'd be working this closely with the Filecoin stack and helping push things forward. So today we're actually going to be using this photo to store with Filecoin storage providers using Solidity smart contracts. You can find this is the actual photo of me trying to get this demo working. We actually first got this demo working for ETH Denver, and I presented at the Filecoin hacker base. It was quite the experience working with the engineers late into the night. They've put such a phenomenal amount of effort into getting this working, and so yeah, it was quite the Herculean task. But I'm happy to be a little bit more well rested and presenting to you today. And if you've seen any of my other presentations, you know I like to talk about imposter syndrome in a lot of my talks, and I just want to briefly mention that here. Like this is like me working with the engineers, trying to figure out how all of this works. I'm still figuring all of this out too. So like, don't feel bad if any of this is confusing to you or feels overwhelming. It is for everybody. I just like to put that in all of my talks. All right, so today we're going to be going through just a short introduction on the Filecoin virtual machine. I want to focus more on the coding side of things. We'll do a demo and remix, deploying a very basic like Solidity contract, doesn't use anything special, Filecoin related in it. Then we'll show an example using the Filecoin Solidity libraries that gives you Filecoin specific functionalities. And then we'll move on to hard hat and making a deal on a storage deal on using smart contracts, which is kind of the special thing we're demoing in this talk. Right. So what is the Filecoin virtual machine? It is a virtual machine that lives on the Filecoin blockchain, right? And it delivers on-chain programmability to the Filecoin network for the first time. So the Filecoin virtual machine is actually made in WebAssembly, but it was built to support multiple runtimes, right? So you'll hear me talking about the FEVM, right? And that isn't running on Ethereum or anything like that. That is running on Filecoin. And how it works is at the base layer, you have the Filecoin virtual machine like running on top of Filecoin nodes written in WebAssembly. And that was designed specifically to be able to virtualize other runtimes on top of it, right? So the first runtime the team targeted was the Ethereum virtual machine, because everyone knows how to work with Solidity at this point in Web3, at least. You know, it's the most common language to use. There's tons of tooling, Remix, Hardhat, MetaMask, everything supports it. So the Ethereum virtual machine is actually virtualized on top of the FEVM. And this Ethereum virtual machine, when you're interacting with it, acts like any other EVM chain you may be used to, whether it's Ethereum or Polygon or Avalanche or what have you. And so to you, it shouldn't look any different, and you should be able to use all of your tools. In the future, this could be extended to other runtimes if they are developed. And there is a roadmap for the team to develop what we call native actors, or the ability to compile smart contracts to WASM and deploy those directly to the chain as well. If you like to program in any language that compiles to WASM, WebAssembly, which is a lot. So yeah, this is the new thing. This is the big new deal, is creating a contract, creating a storage deal via smart contracts. This is a relatively new development, even on the FEVM. And we'll kind of go over how it works. Essentially, we'll be emitting a solidity event that Boost storage providers can listen to and store your data for you. But this is the FIP. Filecoin Improvement Protocol. You can find it in the Filecoin GitHub if you want to read up more on a little lower detail on how it works. All right, so let's go ahead and let's just dive into the coding. Well, again, we're going to start with Remix, and we're going to deploy a very basic contract called SimpleCoin. You can think of it as a simplified ERC20 contract, very basic. And yeah, just going to show off, the EVM compatibility. So let's start out. First, of course, you're going to need to download MetaMask. You can get this at metamask.io. It is one of the most popular Ethereum wallets you can get. I use it as a hot wallet for testing development. Yeah, so you can download it on metamask.io, and you see I already have it downloaded right here. Right. And once you have MetaMask, it doesn't know about the Filecoin chain. It has some default chains it knows about, Ethereum and its testnets, but it doesn't default know about the Filecoin chain. And so we're actually going to point it to Hyperspace, which is the Filecoin testnet, similar to Sepolia or Goerli before it became a whole for-profit thing on Ethereum. Right. So to add Hyperspace to MetaMask, we can just go to chainlist.org, click include testnets. Get this out of the way, and just type in Filecoin. And you'll see here like all of the different Filecoin testnets. Mainnet as well. We're going to click on add to MetaMask for Hyperspace, since that's what we'll be using for the remainder of this demo. Mainnet for FEVM support comes out on March 14th. So no EVM yet, but very close on mainnet. So yeah, you just click add to MetaMask. A pop-up will come up for MetaMask. I already have it added right here. But yeah, that'll add Hyperspace to your MetaMask. And finally, you're going to need to get some testnet fill. Just like Ethereum and almost any other blockchain you work with, you need to have currency to interact with that chain, to prevent spam prevention and to pay the node operators for running all this computation. Right. But on a testnet, you can just get this from a faucet, right? Because testnets have no value. Most testnets now I have to add. So we'll click on hyperspace.yoga, right? And this is the faucet you can use. Now, Filecoin has its own address scheme, which you'll see as like T addresses, so like T4, yada, 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 or T1, yada, yada, yada. But everything is actually compatible with Ethereum addresses, right? So if I just copy my account address and I paste it in there, just the Ethereum address, we get to go through this awesome CAPTCHA, which is always a fun challenge to do live. Now click on the bunnies. Next, bunny. Usually have to go through 2 screens. All right, cool. And click send. And testnet fill from the faucet is on the way to my wallet. It takes about a minute to get to my wallet. We'll kind of go over transactions on Filecoin in a second. All right, but with that, you have MetaMask, you have some T-fill, and we're ready to move on and deploy some contracts on Remix. And I already have Remix open, so that's nice. So once you come into Remix, you know Remix is an online IDE, integrated developer environment. Basically, just a quick and easy way for devs to test and interact with smart contracts. Some people use it for the whole dev flow. We'll go over some Hardhat, a bit more complex tool later. But for now, we're going to go in Remix, and you'll see on the left here, we have a little file explorer, and you should get some pre-built smart contracts, storage.sol. But I've imported these smart contracts. SimpleCoin is one of them, and you can see it here, right? And all SimpleCoin does is it's a very simple coin. It takes a constructor. You can pass in a value for the tokens you want to be minted, and it will mint it to whoever deployed this contract onto the FEVM. And we just have a function to send that coin to other addresses and getter functions to get the amount of token held by a specific address. All right, so we're going to come to the compiler tab, click compile simplecoin.sol, and everything is good. I have auto compile turned on to make my life easier. And we'll go to the deploy tab, right? You're going to want to make sure that injected provider MetaMask is chosen. When you come in, it will default to Remix VM. That is a local VM within MetaMask, and it doesn't interact with any blockchain anywhere, just this like virtualized chain on your browser. Injected provider MetaMask will tell it to send all transactions through MetaMask. And because my MetaMask is pointed to hyperspace, it is going to go to hyperspace. And it looks like I got my 5 T-fill added. So that's awesome. Right. So then you're going to want to make sure that the contract you're pointing to is the one you want to deploy. We're going to want to deploy SimpleCoin. And we're going to put in the constructor, since that has to be filled out before we deploy it, to 1,200 tokens. That's how many I'm going to mint for SimpleCoin, and they will be assigned to me again. If I click deploy, we'll see MetaMask comes up with a transaction. It's going to estimate gas fees. We're going to click confirm. So if you're used to gas on Ethereum, gas on Filecoin is actually calculated a bit different, and it does use Filecoin gas and not the traditional EVM gas. So the gas calculations, you can find more detail in the docs, but they're based on WASM time runtimes for all these computations, as opposed to the hard-coded gas values that you'll find in most Ethereum runtimes, right? And so that's going to take about a minute to deploy. It's going to take some time. So I have a pre-deployed contract we can look at while that goes through. So you can load any contract right here as long as you have the ABI and the address it's deployed at, which Remix has the ABI since we have the contract in here. And we'll just click add address. Oh, and it turns out my contract deployed at the same time. So that's convenient. We'll just go ahead and look at the contract we just deployed. All right, so if I copy and paste my account in here and click balances, boom. So I have 1,200. The 1,200 I minted to myself to initiate this token. And yeah, so that's simple coin, right? So this is just basic solidity working on the Filecoin-EVM. But now I know that that's cool, but why EVM on Filecoin, right? There's a million other EVM chains out there. And remember, the history of Filecoin is that it was designed primarily for decentralized storage, storing the internet's data. And I find that this is a very important part of the Web3 stack, right? A lot of front ends for Web3 dApps are actually hosted on centralized servers. And so Filecoin is kind of there for cold storage, right? Which is a very important like sector, right? So we don't have to trust on any like one centralized entity, right? And so the Filecoin blockchain actually monitors the storage deals, right? The metadata for these for the storage providers, right? And so how can you access these storage deals? You can do them through these Filecoin Solidity libraries created by our friends with the team Zondex, right? So let's take a look at them right here. And I'm about to go into some more detail about storage deals in a second. Right, so these are basically Solidity APIs. You can't use these on any other chain because these are specifically for the FEVM, and they take advantage of these native actors, we call them, for interacting with storage deals. It is in beta at the moment. It is being audited as we speak and should be ready very soon. But I just need to put that disclaimer. And yeah, you see the README kind of explains some things. If we look in the contracts directory, you'll see here we have APIs. These represent APIs that were already open to Filecoin, but this opens them up to be used in Solidity. So if we look at the market API, Solidity contract, this actually opens APIs like a bunch of getter APIs for getting information about a specific deal on chain, getting the actual PCID, getting the client who asked for the deal, getting the provider, the address of the provider who's storing the deal, and so on, right? So these really, using these in your dApps really opens up the world of the FEVM when compared to other EVM chains.
Hey, Zach, when you're in Remix, can you zoom in a little bit as well?
Oh yeah, sure, yeah,
Okay.
no problem. I'll make sure to do that when we go to the next contract.
Okay.
Yeah, appreciate that. Cool. So I'm mentioning these deals, right? So let's talk a little bit more about them and how they're created in the past and how we're going to create them later on in the demo, right? So if we go to Filefox, which is a block explorer for Filecoin, you can click on the blockchain tab here and click on deal list, right? And these are actual storage deals on chain. If we click on one, this deal ID right here, you have the provider. These are usually miners on the Filecoin network and their address, their ID. And you have the client, right? The address of whoever requested data to be stored, right? The data that are stored here in this deal is 32 gigabytes. And you can see when it was stored and the PCID, aka basically you can think of it as the root hash of the data that's stored there, right? So we're going to talk a little bit more about that root hash that I mentioned earlier, right? Also known as the PCID or the COMP, right? So you'll see this big graphic it may look confusing, but it really isn't much. Essentially, you take a file. Let's say it's that cat photo that I showed earlier, right? And you want to prepare it to be stored in a Filecoin storage deal, right? Well, one of the first steps is you're going to turn it into a CAR file, right? A compressed version of the actual file. And then you're going to want to compute what we call the IPLD DAG, directed acyclic graph. Confusing, it's just like a tree. If you're familiar with like the inner workings of Ethereum, a Merkle tree, or a binary hash tree, that's essentially what it is. Right, so it's going to take that data, it's going to take that file, that compressed file, it's going to split it up into chunks, and then it's going to hash each of those chunks, and then create a tree hash all the way up until you get your root hash. And this allows you to get like a hash that represents the whole data. And so that kind of just represents the raw file or the raw compressed file. We actually you're gonna want to pad the file to make sure it fits. And there's tools that do all of this. We're going to use one later in the demo with some zeros. And essentially, when you send this to a storage provider, you're going to send this padded compressed file along with the IPLD graph or DAG to the storage provider. And they're going to confirm that, your file does, in fact, hash to that PCID or that root hash. And that's going to be what represents your deal on chain right here, right? So long story short, file, we create this graph, we get this piece of data that represents the file, and that's what we send to the storage providers to store our files. So this is how deal making works at the protocol level and how it worked specifically before the FEM was a thing, right? Essentially, you, the client, or whoever wants to store the data, would decide what data you want to store. You would use a tool of your choice to compress it and create that file that we talked about earlier. You would do some research on storage providers and what deals they're offering. Maybe you know a storage provider and you can negotiate with them. Either way, say, okay, you kind of find a deal that you think works. You need to lock some funds in escrow so that the storage provider knows you have the funds to pay for the deal over time. You send what's called a deal proposal to the storage provider, right? And the storage provider will look it over and make sure that that's what y'all negotiated or what they deem as a fair deal. The storage provider would then say, okay, this looks good. We're ready to accept this and publish the deal. So then you need to actually transfer the data to the storage provider, right? And all of these steps, there were tools to do this. There's marketplaces you can look to find storage providers. But yeah, this is quite a manual, process. There was also things like Web3.storage and NFT.storage that do all of these steps for you and make it a lot easier. But yeah, you would transfer the data over. They would make that check to make sure the data is actually what the PCID that's in the deal. And then they would call a function on the Filecoin APIs called publish storage deal. And that would actually, prepare them for storing the data. And so that's kind of the traditional way of making the deals and how everything worked with the FEM. I know that was a lot of information, so I'm going to go ahead and check the chat to see if there's any questions about any of that before I move on. So yeah, if you have any questions, feel free to drop them in the chat as we're going on, and I'll try to make periodic checks like this.
Yeah, there was one question from Harsh. how FEVM mainnet would lead to burning, Phil?
Burning. Phil, yeah. So Filecoin, just like Ethereum, has a similar implementation for EIP 1559. So every transaction that's sent to the Filecoin blockchain, some of that Phil is burned, right? And so with the Filecoin virtual machine live, you would expect more transactions to be coming through now because there's more utility, and that probably increase the burn of Phil. Yep, and I see some feedback on zooming in. We'll make sure to do that when we go back. Okay, cool. So I think that answers all the questions right now. So yeah, we kind of talked about the traditional way to make deals. You can still totally make deals that way, by the way. None of this deprecates that. Filecoin still works that way. This is just adding on functionality and new ways to make deals using smart contracts now, right? And so one of the first ways we demoed how to do this was what we call the bounty hunter method. And there's a contract you'll see in my hard hat kit later that does this. But essentially, it's just a smart contract where you take that piece CID, again, that piece of data that represents it, and the size of data you want to store, and you just create a bounty in a smart contract for that, right? And so this is a very useful tool, I would say, for like DAOs. Like maybe you're a decentralized science, a DeSci DAO, and you want to crowdfund for a specific piece of data to be stored on the Filecoin network. You can use this flow to say, hey, this is the PCID for the data. This is the size of the data that we want stored. Let's crowdfund and see who can actually get this data stored on chain for us, and we'll reward them. And it actually uses the Filecoin libraries to make sure that the payment is sent to the address of whoever made the deal, right? So this is one way. This is just kind of like, hey, please someone make my storage deal for me. This is what we're going to demo in this later on, is an even more automated flow for making a deal, which now, let's say I have some data I want to store. I generate the car file and the DAG, and I want, in part of my smart contract flow, I want to be able to call a method to store this data, right? And so we can actually call a function in Solidity as long as it admits that event I talked about earlier, create deal proposal. Boost storage providers can listen for that event to be emitted from the EVM and read the data from it and use that as the deal proposal, right? And actually store your data from that. So we're going to tell them, hey, we have this already pre-prepared data in a server somewhere. Here is like the deal proposal. Here's how much I'm willing to pay. Here's the collateral. Here's how much collateral I expect from you, and how much this is all going to cost per block, and send that into a function in our smart contract. That function then emits an event. The Boost storage provider sees that event and says, hey, that looks like a fair deal, takes it up and stores your data, right? And a core thing I do want to point out here is that when the storage providers actually store your data, they are writing proofs to the Filecoin blockchain that they are storing your data. Like, that's super important, right? That's how we keep this all decentralized, is that we're not just trusting the storage providers to keep your data, live. They actually have to provide proofs in specific windows, and if they don't, they risk getting slashed. So we're going to first go through a demo in Remix again, using the Filecoin example contract I call the Filecoin market consumer. It just uses that Zondax Filecoin Solidity library and gets data for a specific deal on Hyperspace, right? It's all the same things. We're just going to go here back to Remix, and I'll zoom in. Hopefully that is better. And we're not going to do simple coin. We're going to come back here and we're going to do this Filecoin market consumer, right? Really basic contract. We just have a bunch of state variables and a bunch of functions to call those getter functions in the market API for the Zondax, right? So we're just calling all these getter functions and storing the data in our smart contract in these state variables here, right? And then I have one function that calls all of these mini functions, store all. So yeah, I see a question for repos which showcase the Filecoin storage deals working. Yeah, we're gonna get to it right after this demo. So yeah, we're just gonna compile it. Here we are calling the Zondax libraries. And just like everything else, make sure it's injected provider MetaMask up here. It's pointing to Filecoin market consumer. You can hit deploy. Again, to save us some time, I'm going to pull in a pre-deployed contract. So we don't have to wait for the transactions to go through. Oh, not that one. Let's see here. Throw this right there. All right, so if we go to Filefox, we're going to go back to the main Filefox page. We're on mainnet right now, and we're actually working on hyperspace. So we're going to switch the network it's pointing to hyperspace. And let's pick a deal we want to pull information on, right? So let's just get information for deal ID 1011. And we'll go to remix. You can store deal 1011, click store all. We'll confirm our MetaMask transaction go through. Again, we are paying gas fees. It is going through with that EIP 1559 like structure where some of the fees are getting burned. But yeah, this should update with our information for that specific deal. If we look here, we actually have this old deal with old information in it since this is a pre-deployed contract. And when this transaction goes through, we'll come in and we can see that hey, this deal matched with that. But it's going to take some time for the transaction to go through. So actually why transactions take time on the Filecoin blockchain is because there's what's called a delayed execution model, where it takes about 30 seconds for your transaction to be actually included in the chain, and another 30 seconds for your transaction to actually be executed, right? And yeah, so that's why it takes about a minute on average. So our transaction has gone through, and let's look at some of the information here, right? So our size is 262. Let's look at here. Yep, so 256 kilobytes. That's about where we're at on there. And this is actually that PCID, but serialized and represented as Ethereum bytes, right? So if we convert it to the representation, CID representation, which I believe is base 64, it can be represented as a CID that we see on chain. The price per epoch, which is 0 since this is on testnet. The deal provider actor ID 1036, which is their deal ID right there, right? So we got the information from that deal in our smart contract, and you can use this to create all kinds of cool logic, other applications that you may have heard earlier, like data DAOs or perpetual storage contracts, all kinds of things we're excited about to be built, right? Okay, so now we're going to move on to the new cool part, right? And we're going to actually create storage deals with that method I talked about earlier on Hyperspace. And we're going to do it via hard hat. right? So you can find this nifty hard hat starter kit under the Filecoin project GitHub, right? And here you'll see, if we go into contracts, you'll see the basic solidity examples. There's a simple coin we deployed earlier. You'll see that bounty contract I talked about. In the market consumer we just interacted with. But we're actually going to be dealing with basic deal client today, and deal client.sol specifically, right? So let's go ahead and we're going to clone this repo. I'll try to get this. Oh, got to minimize this. So we're going to go into a terminal, right? You see I already have another repo open here, but we're just going to walk through this real quick. We're going to do git clone, and we're going to paste in that repo name. Make it big so it's easier to read. Hit enter. That's going to clone it in there. We're going to type in code. I have the VS Code shortcut that'll automatically open this in VS Code. Yep, we don't need to update right now. Oh, I'm actually one directory up, right? So let's cd into the FEVM hard hat kit. Now we'll open it from there. And I'm goofing with my typing abilities right now. There we go. All right, cool. We'll open a terminal in here. Right, and one of the first things you're going to want to do is type in yarn to download packages. Right, and this will get all the packages that we need into our project. And while that's going on, we'll just kind of talk about how this works, right? So again, just like I showed you in that repo, we have all of those contracts, including the deal client.sol contract. And it's going to give us some problems just because some downloading the yarn, but it's fine. We have a deploy script right here that deploys each of our contracts. And we have, very importantly here, tasks, right? And these tasks are how we can interact with our deployed smart contracts once they're on chain. So if we go to, for instance, the market consumer, we have a task that calls that store all function, right? And sends it on chain. But what we're going to focus on here is we're going to go back to deal client.sol, and we're actually going to focus on calling this function make deal proposal, right? So it takes in this struct called deal, and stores a bunch of information on chain, does a lot of stuff, but the most important thing is it emits this event, deal proposal create, right? And that's the event that storage providers know to look out for. And if you want to see that struct, here's our deal request. We're going to pass in a PCID, a piece size is the deal verified on Fill Plus. The label, which is usually the raw CID before we do any padding or anything to the car file. When we want the deal to actually start, the epic we want it to start, when the deal will end, how much we're going to pay per epic, the collateral that the provider puts up in case they need to be slashed, the collateral the client puts up or you, the client, puts up to prove to the provider that you can continuously pay them for their services. And these extra params here are where some interesting magic happens, right? So this is where we're saying, the Boost storage provider sees that there is an event emitted in Ethereum, and that they want, and they say, okay, this proposal looks good. I want to store that data, but they need to retrieve that data from somewhere, right? So we need to have that in some kind of open server somewhere else, right? So yeah, see, there's still some maybe issues with reading it. So hopefully this makes it a little bit more clear. Yeah, so that's kind of what we're doing here. We're giving them like an HTTP ref or IPFS reference and the size of the file that they're actually going to store, right? And then to deploy, you just type in yarn hard hat deploy in the console, hit enter, and I'll run the script and actually start deploying our contract. Oh, of course. One specific thing I missed here is we need to add our private key in a .env file, right? So you're actually going to want to create a .env and then put your wallet private key in there so Hard Hat knows what wallet to send this transaction with, right? And you can do that by going into MetaMask. And again, I always have to put this disclaimer: never ever show your private key to anyone, and never ever check this into Git. If someone gets your private key and you have mainnet funds in that wallet, they can and most likely will steal the funds, right? This is a dummy account I use just for demos. So there's no real money associated with this, and I want to show you the steps. But again, you know, this is not advised to ever be shown, right? So you're going to go here, we're going to type in our password in MetaMask, and we're going to copy our private key over. So please don't steal my poor testnet fill. You just type in private key. I'll put it in some quotes, paste, save. Now we'll type in yarn hard hat deploy, and our deploy script will start deploying it's going to compile our solidity files and it's going to start deploying them, right? We're not going to wait. That's why I have my other demo open. So we're just going to go ahead and close that. And we're going to go to the pre-deployed one, which real quick. Go ahead and open this. All right, so in this repo, we've already deployed the contracts. Everything is good there. You know, we've done the yarn. I have the .env file, and so we're almost ready to call the method. The last thing we need to do here is we need to take a file, and we need to generate that car file, and we need to store it somewhere, right? So let me make sure this is big. Maybe that's a little too big. So what we're going to do, let's see, do I have my Explorer open here? All right, so if I just go to my pictures right here, you'll see I have my cat photo, he attack.jpg as opposed to he sleep. And so that's the file we're going to turn into a car file, right? And how we're going to do this is we're going to use this tools go generate car tool right here, right? So if I cd into tools and I cd into go generate car, you can type make. I've already made it. This will compile it. This tool is written in Go. Hopefully we'll write this tool in JavaScript, so it'll be a little bit more native to Hard Hat, but for now it's written in Go. So make will actually compile the program, and we can call it from this directory, right? So if what we're going to do is we're going to, and just to save time, I'm going to put the script in here. We're going to call in this directory generate car. We're just going to say, hey, it's a single file, and this is where the file is, right? And it's he attack.jpg. And this will actually generate the car file, right? And the IPL DAG that goes with it. So if I hit enter, you'll see we have all these CIDs that generated. The very important one we need is right here under data CID, we have PCID, right? So that is the CID of the file that we're going to store, and that's the PCID that we're going to use to represent this to the storage providers. Now, if I ls, you'll see here, this is that CID.car, and this is the size of the file we're going to store, right? So we've generated the car file now. We know the size of the car file. We want to actually put this somewhere that the storage provider can store, right? This could be anywhere, right? This could be any open service, but an easy one we're going to go to today is web3.storage. Right, so we're just going to type in web3.storage. Right, and I'm logged in, and we're going to click start now. And here you can just upload files, and web3.storage will actually go through that traditional deal making flow and make deals for you. But what we're actually using this for is they actually just store your data in their IPFS gateway, and anyone can kind of pull it up that way, right? And so that's what we're going to use, right? So, I uploaded the raw file here, but here is that generated car file. I click on the CID, will come up right here. And this will pull up like the gateway for it on IPFS right here. And that's actually what we're going to pass through and use as the URL to signal to our storage provider we want to store this file. Okay, so all of that said, we now have our files stored in a server somewhere or IPFS or wherever that the Boost storage provider can look for. We're ready to call that function make deal proposal, pass in all of our deal information, and see hopefully if the storage provider picks it up, right? So we're going to go back out to the main Hardhat Kit directory here. And we're going to call this task make get deal proposal. And you see there's a lot of parameters it takes in. And so I've actually, this is one we're going to copy and paste into the terminal. Here, and I can just show you because I have it in a Google Doc right here, right? This is the task we're running. So Yarn Hard Hat tells it, okay, and then make deal proposal is the name of the task. And we're pointing it at this contract I've pre-deployed. And we're giving it the PCID of the data that we have stored, the size of the data, the verified deal is false, and we're passing it all this information in and where it can actually find the data to store. So that's the actual full task I'm running. We'll hit enter. And this is going to take a second to go through again. It's making the deal proposal in network hyperspace. And we're going to look at something cool because I'm actually SSH'd into a Boost storage provider, right? And so hopefully we can see it pick it up live, right? So here is a GUI for the Boost storage provider. And hopefully once this deal goes through, once the transaction goes through, we'll actually see a new deal added on here that the deal proposal picks up, the storage provider picks up. So we'll just give this a second to go through. We can kind of look here at the GUI for the Boost storage provider. So Boost is just a kind of helper binary you can run that storage providers typically run to make it easy to deal with storage deals and visualize them with this convenient GUI. So they're usually run alongside a Filecoin node, like a Lotus node, right? So yeah, so this task is going to go through. It passes everything in, and then actually listens for the event, right? And boom, you see our transaction went through, it emitted the event, and right here, the storage provider has seen that event, and it's actually pulling in the data, right? It's saying transfer is stalled. That may be because of like a HTTP gateway. It'll try to redo that, right? And boom, there we go. So it's transferred the data. It's made all the checks that the PCID matches the file, and it's saying, hey, this deal is good to go. Everything looks good, and we're ready to publish the storage deal. So after that, if I was this SP, I can just come here and click publish now, and it's going to publish that deal on chain for me. And of course, this SPs probably have automated systems to do this. This is just a very manual way to demo how this works, right? And again, the data they're storing is that picture of my cat, right? All done through smart contracts. So very excited about this. If we click on the deal here, you'll see that the client address is like a Filecoin client address, a T4 address, right? But if we actually copy this, it's not actually we'll just open it up, and we'll copy it right here. If you copy this and you go to like a translator tool, there is one in the hard hat kit script that will actually translate addresses for you. If you type it right here, no, because this is converting. We'll just put it in here. Oh, and we need to put it on hyperspace. That's the issue here. So if we do that, you will see that this is the ETH address of the contract that we emitted. So it views the contract itself as the client of the event, right? And we can also look up this contract on Filefox, on hyperspace. We could put in the Ethereum address or the T4 address. Either one works. So it's going to say actor EVM, and it's going to show these. This is the transaction we made with the make deal proposal, and the the events we emitted, right? And so yeah, this is the full workflow. This is how you create storage deals on Filecoin. And I'm going to blast you with a bunch of resources now before I save a couple of minutes for Q&A, right? So let me see here. Again, here is the Hard Hat Starter Kit. If you missed it, you can find it in the GitHub for the Filecoin project, FEVM Hard Hat Kit. And if you go within Hard Hat Kit, you'll actually see, if you scroll all the way down, I linked to Foundry kits for each of the client contract and the bounty contract. That's where they're being developed currently under the Lotus project. We are going to kind of bring all of this together. But if you are like kind of privy to Foundry, you can look at these, and they have a little bit more technical, detailed readmes. And I also want to shout out a community-driven Foundry starter kit, right? So a great community member, very active, Xinghan, developed this Foundry kit right here, and he's a very active community member. He's active on the ETH Global Discord as @peep, and yeah, I'm just like super proud that this is getting made. He's updating it constantly. Very knowledgeable community member, and yeah, we're gonna work on getting this, completely up to par, and this will probably become the official Foundry starter kit that we push everyone to. So thank you very much, Shinhang, for such an awesome job. And my colleagues, Matt and Sarah, are actually doing Twitch streams now, twitch.tv/PhilBuilders. The next two streams will be March 16th and 23rd at 9 a.m. PST, 12 p.m. EST, 5 p.m. UTC, right? So feel free to go jump on those streams, ask questions. You'll find me there for some of the streams for sure. But we're excited to launch these Twitch streams. There is a request for startups out. So if you are a startup and you think you want some support, some kind of maybe some grant funding or just seeing what's going on with mainnet, feel free to come over here to the request for startups. So rfs.fvm.dev. And finally, all of this was done on Hyperspace testnet, but this will be launched March 14th next week. We are super excited on Pi Day, of course. We are all nerds over here and we love it. So you can watch the event for the FEVM mainnet launch on the Filecoin YouTube. And please go there, subscribe, wait, it'll be a big deal. And finally, for everything else, my colleague Sarah has made this awesome link tree that just has a bunch of other resources on it. An about page, the docs. This hackathon cheat sheet is really convenient if you're going to be on the hackathon. It really combines all of these resources that we've talked about. It's up to date now, and yeah, super useful resource. And finally, we have our mainnet cohort, which you can apply for as well, which is just a combination of teams that are all looking to deploy to mainnet and are ready to go and become active members of the Filecoin-EVM launch. So thank you so much for listening to my talk. Looks like I have just a couple of minutes to address any questions in the chat, and I see there are some. So I will try to answer them.
Yeah, one of the first ones was, were there any libraries other than Go for creating car files?
There may be, I think there might be a JavaScript library out there somewhere. I'm not sure if it's up to date and how well it works. Right now we're using this, but we are working on making more libraries, and we're actually working on with the community to make a front end that will do all of this for you, right? So just like a convenient web app where you can go in, upload a file, it'll generate the car, the DAG, everything, store it somewhere that storage providers can take up. And that'll be all done in the browser. So we are definitely looking forward to that.
And William asked, what is the difference between the piece CID and the CID when you get when you upload the file to IPFS?
Yeah, that's a great question. So the IPFS CID is actually just kind of the raw, called the COMD CID, where you just take the file, turn it into you generate the IPLD DAG for it, and you generate that. The PCID is very specific since storage providers want these specific formats. So we turn it into a .car file, we do that padding, and then that CID that we get is the PCID, right? So it's just a very specific CID, but they look identical, right? And if you were to put that car file with the padding and everything on IPFS, I believe that might be the same CID that you would get, but don't quote me on that.
Okay. Harsh asked, how to access the data once stored, like via IPFS only?
Yeah, so that's like the retrievability side of things. There's a lot of cool projects working on that. You can go to the, I believe it's the Lotus docs, has a section on retrievability on here. You can also use a service like Filecoin Saturn, which is new. So this is basically I don't think this works with Filecoin, like it works with IPFS, but not Filecoin just yet, but it is working. So this is a CDN that like caches IPFS requests and makes them super available. Anyone can run a node. You can go to saturn.network, and they are working on being compatible with Filecoin as well to make data available on Filecoin retrievable, right? So there's a lot of options. Search up Filecoin retrievability, and it's being made easier every day.
And what are the key advantages over IPFS? Stephen asked that.
Fantastic question. So IPFS, is its own peer-to-peer network for file sharing. I can pin data on IPFS. I do all the time, and it's there. But there's no guarantees that your data on IPFS will stay there, right? Like if everyone stops pinning that data, it's gone, right? And someone could always repin it, but there's no guarantees, right? Filecoin, we have very strong guarantees that the data will still be stored because the storage providers have to provide those proofs on chain that they have it, or else they risk slashing. So they're directly incentivized to keep your data, right? So Filecoin is really used for like cold storage of data that you want very strong guarantees will be stored and available.
Awesome. Okay, and that was all the questions in the chat.
Awesome.
A little bit over. So yeah, just thank you for joining us today, everybody, and thanks, Zach, for the great presentation. I'm going to drop in the Discord, the Filecoin Discord channel. If anybody else has any other questions, feel free to reach out there.
Please do. And thanks so much for having us. This was awesome. So I hope all of you found it helpful. Feel free to reach out to us on the Filecoin Slack, on the Global Discord, and anywhere we can be found, and we'll try to reply. And happy hacking.